is a professional embedded software developer and very open to collaborate and contribute towards complex and challenging software projects from specification to sustenance, utilizing his experience in embedded systems, networking, and product development. He also has experience in designing and implementing application software. He has good exposure as software architect, designing complex software modules using patterns-based approach and modular and extensible code. He strongly believes in providing world-class services and products to increase client experience or happiness, directly impacting the business outcomes. In fact, he is also fascinated with the intersection of various technologies and how they solve bigger problems. He always tries to make things simpler and comprehensible. When he is not with the currents, voltages, architectures, and their manipulations, he indulges in history and cooking. Interesting. He also tries to keep things simple by trying to connect them to the first basic principles. Vamsi Balemarthy follows the idea of inventing in oneself. It is the greatest service that one can do for the society. It is only capable people that can change the world. That is the philosophy which he strongly believes in. So, folks, in today's episode, let's learn more about Vamshi's journey in becoming embedded software developer and also get his insights on embedded software architecture. I'm sure most of you might have heard about the regular software architecture in terms of understanding the design patterns that are involved to develop applications, be it the MVC pattern or any other pattern that you have come across. But how are these software architecture for embedded systems different from the conventional software? Let us dive and learn more about it in today's episode. This is the Guiding Voice podcast series, TGV, for a better future. This podcast is to help professional students, IT employees, and entrepreneurs to shape their careers. So, folks, in case if you have not rated and reviewed our podcast on Apple or Podchaser, request you to provide your rating and leave a candid review. This is your host, Naveensamala, and I have about 18 years of rich and diverse experience in the IT industry. In every episode, we interact with industry experts or thought leaders or academicians or coaches across the globe to drive some insightful conversations that will help each one of you learn some amazing stuff. Also, we share an interesting trivia or a fun fact towards the end. In fact, you will acquire more knowledge by tuning into TGV per every minute than any other podcast in this space. Thank you so much for tuning in. And pleased to welcome Vamsi, part of TGV's journey in shaping the careers and lives of millions across the globe. Vamsi, welcome to TGV.
Thank you very much, Naveen. It's my pleasure to be part of TGV. Heard about it, regularly follow your posts on LinkedIn, engage with you, and have seen a couple of interactions that you have done with Miss Pratima and other people.
Yeah.
Thanks a lot for making me also part of this your journey.
Thank you. And it is absolute pleasure to connect with you. In fact, you have been posting some valuable content on LinkedIn and helping the fellow professionals learn, right? And I love the spirit. Keep doing that. In fact, it is very inspiring. All right. So without further much ado, let's get into today's conversation. So Vamsi, I always ask my guests, what are top things that have contributed you to become what you are today? Can you share with our audience?
The first thing would be being pragmatic or practical, because I believe many people talk, and talking just will not yield results. They can inspire, yes, they motivate, definitely, and they can give a way, guide a person. It is as simple as a holy master trying to show a path to the student, but the journey is supposed to be done by the student, which itself is an action. So that is one thing. And the second part thing is attention to detail. On a higher surface, everything seems to be simple. Somebody may say that, what is there so much in running? But you run once to understand what is there in it. So being practical and attention to detail. And the third important thing is dig deeper. It goes along with that attention to detail, wherein you need to dig deeper to understand. So these all are like three legs of a chair or a stool that on which you can actually sit. Remove one thing, the stool cannot stand and you cannot sit.
Oh,
Yeah, these are the top three things.
quite a fascinating set of thoughts out there. And I really loved this statement that you made. Some holy master trying to guide the student, and student have to take the path themselves, right? And definitely this having practical exposure is going to play a very critical role. Thank you for bringing that up. So with that, let's jump into today's core topic. And during my intro, I mentioned the regular software is a bit different from embedded software, right? And can we highlight very briefly about how the embedded system software is different from the regular application software?
It's not a rocket science. The name itself says it is embedded, so you can't see it. That's the biggest thing that people always stumble upon when they start their journey with embedded software. People are used to gadgets, those fancy and exciting GUI. Sometimes we see the world around us through our eyes, which is obvious. But people who are not having sight, they do perceive the world, but with their own senses. So embedded software, I'm trying to draw a parallel between people who have sight and can see the world through their eyes, but there are people who can still perceive the world. What I'm trying to say is the world is around us. It's not going anywhere. But the means through which you are able to perceive the world and see the mechanism and the tools that you are using, they are differing. In the same way, just because I am not able to see some software doesn't mean that a device which is silently sitting somewhere doing some repetitive task is not intelligent enough. It has its own intelligence. And that software which sits there doing that activity day in and day out without disturbing you, sometimes blinking a small LED to give an indication to you. These type of devices, when you see, please understand that it's an embedded software and there is a person behind that software who spent his days and nights designing and trying to make that software as much bug free as possible.
You made it very easy to understand. And in your introduction, I mentioned you love making things simple and comprehensible. In fact, I love that LED light example and all those devices that are silently working. There is a lot of hard work by professionals, and there is a ton of code that is running right behind the scenes. Wow, quite
Yes.
interesting.
Yes.
Now let's talk about the software architecture for the embedded systems. Like, how is it different in from the conventional software? Like, are they same?
Yeah, the answer is both. Yes, it is same and it is also different. Same in the sense that human factor that goes into design of the software and some architectures, especially because the language that people use, mostly the C language, that would be same. If at all they are trying to create an application based on C and also trying to write embedded C, many of the constructs that are provided by the language are same. Let me again take a very simple example. Everybody has their own mother tongue. There are books that people write and that were written and that will be written in that particular language. Going back some 200 years, somebody, a great poet, might have written using the same language but different vocabulary, a masterpiece. And today's generation, if we ask them, they understand that okay, it's my mother tongue, I know that, but I'm sorry, I cannot comprehend the meaning of these words. What I'm trying to say is the usage of the language in both the domains, either an application domain and like when it comes to embedded software, there is a difference. And when you come to architecture and all those things, embedded devices really do not need such a big architectures that are needed for user space applications and GUI applications. The so-called hi-fi design patterns and all those things. Yes, we can adopt them. There is good amount of literature which even speaks about that. But a very rudimentary while one loop or an infinite loop is sufficient for an application of decent complexity where you want to control some activator, enable something, and then embedded world is full of interrupts. It's like those distractions today. Now we have the phone, the phone call, or some message, or some indication on the phone screen, which interrupts us in our daily activities. We are engrossed in our daily activities and suddenly we see something and we get distracted. Embedded devices are like that. It wants to do one activity, but somewhere some sensor will say, or some hardware device wants to get the attention of the CPU. Then it will raise something called as interrupt, and the CPU gets interrupted. It was otherwise doing when its routine task, and then it addresses that interrupt, and by talking with that hardware, let me put it like this, and do whatever is needed. From that basic rudimentary while one loop or an infinite loop, that's so called, it's also called super loop, with interrupts, we can go and bring in grand structures. And during the introduction also, you told there are design patterns and MVC and all those things. All these things can be applied, but there is only one concern here. When these abstract things or high level structures come into place, they tend to take space. So the choice is like, if your device can't afford to have that space and it has small real estate to hold that content or the program logic, better not to get those things. Otherwise, a decent operating system which has these high level things that can be incorporated at a very basic task which can be scheduled, be enough to address majority of the requirements of embedded systems. But depending on the application, people can go to higher level structures like maybe a factory design pattern, because you want to create something and want to delegate something, so you can delegate something. So these sort of higher constructs also can be done. It is mainly driven by the requirements, very much more than a GUI application. On a GUI application, yes, so-called people want to make it user friendly and all those things. Here for an embedded system, it doesn't sound very appropriate for me to talk something called as user friendly. You should always think of whether it is hardware friendly and requirement friendly.
Hardware friendly and requirement friendly. Wow, very thought provoking. And you mentioned about this abstraction and delegation, right? Are there any other top design patterns within this embedded world?
Not as a design pattern per se, I will say, but there is a very famous architecture sort of thing, not a design pattern. Like we like it very much, and I have seen that particular mechanism to solve the problems, solving most of the embedded related issues or requirements, because embedded devices are mostly event driven. From GUI also, yes, you trigger events for the software, but embedded devices have events not just coming from the human interaction. It can come from any corner of the world. Somewhere somebody, let us say, rings a bell or steps on a doormat, and if there is a sensor, your hardware has to detect it and it has to respond. So anything anywhere physically outside can become an object of interest, and the data that can be derived from it can be an object of interest for an embedded system. Now these are all events that are getting triggered. So somewhere somebody has to sit quietly and then start looking at devices to see whether any device is giving me an event or not, which calls for a beautiful architecture called state machine. The reason being that, let us say, if somebody creates an event, so a series of post steps has to be done. What after getting the event, what should I do? Do I have to I get it converted? So what is the clarity to which I have to convert, or what is the precision to which I have to convert that number? And do I have to store it, display it, or do I have to do some more modification to that by adding, subtracting, dividing? All those things are some things which you have to do after getting the data from that particular external entity. So these all can be very comfortably devised using state machines. And I can tell you very simple state machine, and C language has it already, which is a switch statement. So switch statement all based on one state of one variable, being it true or false, or its value being n plus 1, anything, one of the cases can be picked up. If else, all those things are state machines. But we want to understand here, like because if we are in an infinite loop, I need to push from one state to another state depending on some mechanism. Let me not digress much into the programming or technical aspects, but at a higher level, a state machine moves from one state to another state, wherein one state can do X number of activities, and then it triggers the second state by providing it some extra information which is required from the first state to the second state, so that the second state can work on that information and the chain can go on.
Wow, very nice. You mentioned about this switch case statement that made me nostalgic during my programming days when we started learning C language, right? These operators,
Yes.
plus, minus, modulus and all, and send that to this particular switch case and execute it. Yeah, very interesting.
Yeah.
All right. So now let's talk some best practices, okay, within the embedded system software development. What would you like to share with our audience?
The single most golden rule, I would say, please understand the requirements. Many a times I have seen not only as a root cause for the bugs, but also with respect to the quality of the code that was developed and also the clarity of the code that was developed is suffering many of the times because the requirement was not properly understood. When I say the requirement has to be understood, when it means do not have any assumptions. If you have any assumptions, spell it out very clearly and talk with all the stakeholders. That, do you mean this? Do you want this? I'm thinking like this. Will something which client wants? So this is one thing which I say a lot. And the second important thing is into process. I know that when somebody is asked to do 1, 2, 3, 4, 5 activities, for every small code change or something, they feel that, oh man, what is this? You are making me go crazy by repeating the same thing again and again. For those people, I would say that people do not put process just for the sake of having a process. They did it without a process maybe some time back, and they saw roadblocks. It is just a mechanism to not reinvent the wheel to solve a particular problem. Just follow the process. Initially, it will be tough, but the moment you see the result. So yesterday, I learned something very unique from one of my mentors called what is in it for me. If I have to ask and answer to a person who is saying that I do not like process so much, I would tell there is a lot in it for you when you adhere to the process. It will save you tomorrow so many hardships or so many difficulties. And I used to always say, a very funny thing in my office and with my juniors. Please write a code so well and extent possible that first thing, your future version itself will not scold you, and another human who looks at your code will not scold you. If you can ensure these things, you are good with your coding and you are satisfying the requirement.
Very enchanting thoughts over there. I loved every bit of it. Something which will resonate with me for quite long is your future version should not scold you and others should not scold you when you're writing code. And I would like to share something from my process hat, because I served as a enterprise PMO leader during my stint with GE. And you know how the program management office works, right? We give them a set of deliverables and which everybody has to adhere to and all. Honestly, that is sounds so rigorous, but there are so many benefits out of it. So in your terms, right, we can avoid the code debt or the technical debt in case if you're following the process. So I resonate with you on that. Great. So after this very inspiring conversation, I'm sure most of our audience would like to become an embedded software engineer. So Vamsi, I would like you to share with our audience how someone can become an embedded software engineer.
First obvious step is be a voracious reader and not reading of books, which is also needed, but read lot of code. We are now living in a world, we are very fortunate actually, I should say, more than fortunate, we are blessed because people have contributed so much amount of code in open source that you do not need a book. You just need to know the language in which you want to program, and then Google to show you embedded projects in C. You will get so much amount of code. And like for the first time when you read the code, you may not understand anything because every embedded code will have a lot of dependency on hardware. If some register is being modified, and so there will be macros. You can look at the code, the header files and other things, and you can make out what is happening there. So it will build a mental model and it will give a feel of what embedded software typically looks like. It is as much as let me give an example. there is a stark difference between people who are, let us say, from China and from India. And many a times I have some of my friends who are from northeastern part of our country. They are confused coming from China or some other part. So in the same way, I also say that even within northern part of our country, by looking at some person, by seeing their name, we can make out which part of the country they are typically, may not be 100% accurate. So reading this code will develop that something what I heard recently called as idea muscle. So there's an idea muscle that we need to develop. If you don't develop, it will just stay like that. But you keep on feeding it with various ideas that you get from reading the code. Then it starts to evolve and it starts to create its own different ideas and patterns. After that, choose one hardware which is very simple to handle. Nowadays, people can pick up Arduino, which is it's the cheapest one, and you can start off with very quickly. Idea muscle is built, and the patterns in the embedded software are known, and the hardware is also available. Lot of YouTube videos and lot of literature spread across internet. You can pick up and can start. I have seen people who are coming from a computer science background start with embedded. They are more comfortable, so-called real-time operating system and just coding, and they try to understand only the requirement, that small fragment of hardware knowledge that is required, and they say that, oh, my job is done. Okay, I coded, it is working, unit test is passing. But it is good to have an understanding of electronics, a basic knowledge of electronics, and something like able to read small amount of schematics, at least to understand what the schematics is trying to say. It is as much as when you go to a dentist, the cross section of your teeth, and if the dentist is not able to read that cross section, then what is fun in that person being called a dentist? You should at least be able to identify the parts of the teeth, right? So in the same way, somebody who is coming into embedded domain should have basic footing. So should dabble in those areas of a little bit about hardware. Need not be very proficient, but they should be able to sit in. See, why I'm trying to tell all these things is software development need not is not actually writing code. It is 80% conversation with people, communicating with people. Now, when you are communicating with people, domain and every discipline has its own vocabulary. Now, when this vocabulary is thrown at you in the meetings, people assume or may not assume, that's a different thing. But in meeting, if these terms are thrown at you, at least you should be in a position to comprehend what is being discussed. Otherwise, you will get lost. And this sort of getting lost in meetings, these have very serious repercussions. That once you reach to your table and your fingers are on the keyboard, you don't know what to do. All this time, while you are in the meeting, but then you are supposed to do something, you are in front of your monitor and your hands are on the fingers are on the keyboard, but you do not know what to do in the precise manner. So get to know the vocabulary, I would say. Yes, you need to work a little bit more than application engineers. This might be a controversial statement, but embedded engineers have to work a little bit more than application engineers. Fortunate thing is, once you learn the basics, your life is almost done. You only have to sharpen the axe. You don't have to buy a new weapon. But application engineers, every 2 years, the language may change, the framework may change, and you need to have a new weapon. You have to have upgradation of weapons. But here, trust the age-old C language, dig deep into it, sharpen your skills every day. That's more than enough.
Sharpen the axe or sharpen the weapon rather than buying a new weapon. Great analogy. I see a lot of analogy to real-time things, and also I think you will make a good, I would say, in case if you were to switch your profile or job. I'm really enjoying every bit of it so far. And since you touched about C language, are there any other popular languages that are used in embedded world?
C++ also is being used. I once went into some conference, not conference, but it's a precursor for a conference for Python. There I met one person who was mentioning that something with respect to Python in embedded domain. I'm not much familiar with that. If I have to think loud why he's saying that, it could be because there is an operating system, and at least there should be an interpreter which can interpret the Python language, and after interpretation, yes, it could be like you are going to write a 5 volts indication, or you are going to write a bit 1 into one of the registers which can drive 5 volts to illuminate an LED. Maybe from Python you can do that. The interpreter can convert it into the equivalent register operation. I see. It is again. I am not into that research part of thing, and I do not think. I do not have understanding about that latest trends with respect to what language is being used in embedded systems and other things. C++, I understand that it is being used. I had discussions with some people. Python, I heard, but to what extent that leading edge literature I haven't seen. But definitely, these all will come with a cost, which is more memory usage. And today, memory is available, but let me tell you, memory is cheap, but it's not free.
Excellent inputs and fabulous conversation so far. So we have been talking a lot about the embedded world and how to become an embedded software engineer. Now let us shift our gears and slightly lighten up the mood of this conversation so far. And maybe we can jump into a quick rapid fire session. I'm going to ask you a few interesting questions and wherein you can answer them very crisply. If you're ready, we'll get started. All right.
Ready.
Great.
Let's go.
Great. So let me fire the very first bullet out of the rapid fire. Vamsi, given a chance to time travel, would you like to travel to the past or the future?
Future.
Okay, fair enough.
Future.
Fair enough. All right. So given that you are a tech geek, right, I'm very interested to understand what is one technology or the gadget that you would like to see.
Automatic cooking machine.
Great. Interesting. And you know what I think about this one? It's about a machine that can feed children. You know how difficult it is to feed children, right? And every mom undergoes that pain, especially during the first 3 to 4 years of age and all, right? Interesting. Let me move on to the next question. So, Vamsi, what is one random skill that you'd like to learn apart from the coding, technology, space, and all, something beyond your job?
Farming.
Wow. Great. All right. Let me move on. What has been a question on your mind for which you never got an answer for?
The rapid fire round, and the question that always bother me is, our minds can generate ideas. People build theories, but I want to understand what is that thing because of which mind can generate an idea. I get a lot of answers, but yes, that's a thing.
You are making me curious as well about that. Wonderful. So let me fire the last bullet out of the rapid fire. Given a chance, which celebrity would you like to meet?
Richard Stallman.
Richard Stallman.
For me, he's a celebrity.
Yeah.
Yeah, he's a father of Free Software Foundation, and I would like to meet him.
Wow. And wish you good luck. I'm sure you'll meet him one day. So this has been enchanting rapid fire. With that, let me flip back to the mainstream and ask you one final question for today's session. So, Vamsi, what will be your one piece of advice to those aspiring to make big in their careers?
Try to acquire, it's also a note to me. Try to acquire knowledge at a deeper level. Surface level things are always temporary in nature. And the knowledge not only addresses the intellectual gratification, but after crossing and after reaching some depths, it will somewhere touch the soul at intellectual level. It may sound a little bit philosophical, but then you have that moment where you just have, they say that I felt, I experienced. So that deep work can bring that moments of happiness. Then I think as if the technology is something that came just for you, and you are the most eligible person to know about that. Not as an entitlement, but as a privilege.
Wow, such a profound set of thoughts. Vamsi, this has been an excellent conversation and I thoroughly enjoyed every bit of it. Thank you so much for being part of TGV's journey in shaping the careers and lives of millions across the globe.
Sure. Thanks a lot, Naveen, and for considering me to share my thoughts for the betterment of software developer fraternity, especially embedded folks.
Absolutely pleasure hosting you. Thanks again for being part of our journey. So, folks, before we move on to the trivia section, right, here is a request from my side. In case if you have enjoyed this conversation just like I did, I request you to share with any of your friends or colleagues who can benefit from this show. Thank you so much in advance. With that, let me use into the trivia section of today's episode. And today I'm not going to share an interesting fact, rather, I would ask you a question from the conversation itself. Here comes my question. What are the top programming languages, okay, that are used for building embedded system software? I, are you thinking that they are C and C++? If that is true, then you are right. All right. So thank you so much for tuning in. And folks, there's so much in store. That's all for today. However, we would like to hear comments and feedback from you, and also kind of topics that you would like to cover us as part of the guiding voice. And we will definitely do every bit to bring in best of the best speakers across the world. Thank you so much again. Take care. Be safe. Until next time. Bye-bye. We're signing off for today. See you all in the next episode with another wonderful guest and cover some amazing stuff.